Now you are going to see that class 10th chapter 1. Prove that root 3 is irrational. Root 3 is irrational. So you have to prove root 3 is irrational. But we don't know what is the definition for irrational. So irrational is nothing but which is not rational, that is irrational. Which is not rational, that is irrational. So we have to prove this one is not a rational. So for that we have to assume first give a number as let us assume root 3 is rational. We have to assume the given number as rational. So we know that rational means it should be in the form of p by q. Rational should be in the form of p by q, where p and q are integers. Not only integers, we can say and co-prime integers, and q not equal to 0 because denominator q in denominator, so q not equal to 0. So we have to prove this one as rational. So rational means we know that we should not have radical symbol, so we have to remove that root. We have to remove the root symbol. For that we have to square on both sides. Squaring on both sides. On both sides. So if you square, root will be cancelled. So p square by q square. So do the cross multiplication. 3q square equal to p square. See, this one is equation number 1. So this, see, p square is equal to multiple of 3. P square is equal to multiple of 3. So it will be divisible by 3. So we can write hence p square is divisible by 3. Hence p is also divisible by 3. Also divisible by 3 because by fundamental theorem of arithmetic, theorem of arithmetic. So what it says, if any number square is any number, say if 7 cube is divisible by 3 mean, so 7 also divisible by 3. If 8 power 9 is divisible by 2 mean, so 8 also divisible by 2. If 15 is divisible by 15 power 9 is divisible by 7 mean, then 15 also divisible by 7. It is a fundamental theorem of arithmetic. Apart from its order, the prime factors should be same. So that is fundamental theorem of arithmetic. So using that, this p square is divisible by 3 means p is also divisible by 3. So p equal to, we can write, because p is divisible by 3, so we can write p equal to 3 some integer r, where r is some integer, where r is some integer. So now we have to square on both sides. Squaring on both sides. So p square equal to 9r square. you substitute this as 2. Instead of p square, we can substitute 3q square from 1. So substitute 1 in 2. Then we get 3q square equal to 9r square. This 3 goes over there, mean 9 by 3 r square. We cancel 3. So q square is equal to 3r square. So see, q square is multiple of 3. So we can write q square. Therefore, q square is divisible by 3. Therefore, hence q is also divisible by 3 by fundamental theorem of arithmetic, FTA, you can write. So see, here 3 is divisible by p. Here 3 is divisible by q. See that p, q both are divisible by 3. So therefore 3 is a common factor for both p and q, but it contradicts our assumption. See, already we assume p and q are co-prime. What is co-prime? Co-prime is nothing but if two number has no common factor, means that is co-prime. See, we assume p and q are co-prime, so it should not have any common factor. But here we have common factor 3, so our assumption is wrong. So 3 is a common factor for both p and q, so it contradicts our assumption. So our assumption is wrong. Is wrong. What is our assumption? Our assumption is it is rational. So your assumption is wrong, means it is not a rational. Therefore, root 3 is irrational. Means proved. See once again. So they are asking to prove root 3 is irrational. So for that we have to prove it is irrational, but we don't know which is irrational. We have only definition for rational. So we have to assume the given number as rational. Then we have to prove which is rational or not. Here we try to prove which is rational, but it contradicts our assumption, because 3 is a common factor for both p and q, so it is not a co-prime. Therefore our assumption is wrong, so it is irrational. Thank you.